In front of me is a copy of the 2025 NHT Specialist Math Exam 2. And in this video, I'm going to go through section B first. Then I will record another video and go through the 20 multi-choice questions. So let's have a look at this question. We're looking at this rational function x to the power 3 plus ax squared plus ax plus 3 divided by x squared minus 1. Write down the implied domain of f given that a is not equal to minus 2. So in this case, I'm actually defining, let's say, this function. Okay, I can use the domain button. So I want x not equal to minus 1 and x not equal to 1. What I'm going to do is write down x is an element of all real except for minus 1 and 1. I'll use the curly bracket here. Alternatively, I'm going to say x belongs to minus infinity, minus 1, union minus 1 to 1, union 1 to infinity. Okay, something along this line. Okay, next one. The rule of f can be written as f of x equals to x plus a plus gx. Using partial fractions show that g of x equals to a plus 2 over x minus 1 minus 1 over x plus 1. So it is important to address the question, say, using partial fractions. But this form is not yet in a proper fraction form, so I will need to change this to a proper fraction form. I'm going to use my CAS here, menu, algebra, fraction tools, proper fraction. And I'm able to get, let's say, this thing here. So then I need to identify these points by g of x and split that in the partial fraction form. Of course, this is a show that question. I probably need to show some working. This bit is my g of x. I'll set it as a capital A, x minus 1 plus capital B over x plus 1. And then I say a plus 1, x plus a plus 3 equals to a times ax plus 1 plus b times x minus 1. And I'll say, okay, for example, let x equals to minus 1. I'm able to get, let's say, minus a minus 1 plus a plus 3. Equals to 0 minus 2b, okay? Something along this line. Then I can cancel out the minus a and get a minus 2b equals to 2. So b equals to minus 1. And then I probably can say x equals to 1. Then I have a plus 1 plus a plus 3. So we have 2a plus 4 equals to 2 capital A. And then capital A equals to small a plus 2. Therefore, my g of x equals to a plus 2 divided by x minus 1 divided by x plus 1. And the question is shown. Okay, next thing is we're going to say, show that when a equals to minus 2, the graph of that has no stationary points. So probably I can just get, for example, f of x given that a equals to -2. You have this expression, and we take the derivative, and we'll get an expression like this. And then we can argue this equation has no solution. This is 2x. This is 2x. And the discriminant is 2 squared minus 4 times 1 times 2, which is -4, less than 0. Therefore, no solution to f dash of x equal to 0. Hence, no stationary point on y equals to f of x. Okay, something along this line. You could also argue, let's say, this is the derivative and its range is 1 to infinity, okay? Something along this line. And therefore, doesn't equal to 0. So no stationary point. You could also use this argument here, okay? Sketch the graph of y equals to f of x when a equals to -2 on the axis below. Label all the asymptotes with their equations and label any axis intercept with their coordinate. Yeah, axis intercept with their values. In this particular case, I'm going to match my viewing window. So I'm sketching this graph. Make sure you, let's say, go from maybe -6. That's right, -6, 1, and 6. Also, if you look at the previous result, you had an oblique asymptote and x equals to -1, okay? And the oblique asymptote, you can see it's x -2, okay? So one thing I will sketch is this thing. Y equals to x -2, something along this line, okay? And yeah. And the next thing is when you look at the shape, you probably want to solve the equation or just use zeros. F1 of x, x. Okay, this is 1 minus root 13 over 2, and this is 2.3 something, root 13 plus 1 over 2. We need exact values. So I'll say minus 1.3. This is minus 1.5. So maybe roughly here. Label that nicely with their values. The question says the values. I better write coordinate pairs. 1 minus root 13 divided by 2, 0. And 2.3 something. Here. Plus root 13 divided by 2, 0. And also you can calculate f of 0 minus 3. 0 minus 3. And can I notice other values? If you look at the grid points, probably I would say this is a minus 2, minus 3. Here, here, and yep. You can just graph this one nicely. Show some really good asymptotic behavior, okay? Show some really good asymptotic behavior. Okay, that's one branch. This one. Because for all the graph questions, I take extra care. Don't rush, take your time. Make sure you get a single smooth curves, okay? Because graph is worth 3 marks. And then finally, this graph doesn't have any, let's say, turning points. So, yep, the 2 branches like that. Okay, so that is the graph. Let's move on and look at other stuff. Using f of x equals to x plus a, or plus x, a plus 2, x minus 1 minus 1 over x plus 1, find f dash double dash x, where a is an arbitrary real constant. Give your answer in the form 8. F double dash is this form. Well, a, b, and p are real numbers. So I'll say, I'll go back and find the expanded form. Now I haven't got the expanded form in terms of a, so just do it here. Expand f of x, comma x, something like that. Then I just take the second derivative, use the expanded form. You'll be able to get something like that. And you can check this p-value is like a 3, and this a is 2, and b is minus 2 in this case. Don't confuse these a and b with my previous values. They're different, okay? Okay, so that is the second derivative. Hence, verify that the graph of f of x has no point of inflection when a is minus 2 and a is minus 1. When a is minus 2, your f double dash x equals to, this is a 0, so 0 divided by x minus 1 to the power 3 minus 2 over x plus 1 to the power 3, which is minus 2 divided by x plus 1 to the power 3. This is never equal to 0, as the range of f double dash x is r backslash 0. And you can see the graph, if you look at the graph, just this bit. It looks like that, okay? Very similar to a rectangular hyperbola. You can draw something like this if you wish, if you have time, okay? And that is, this graph here. And if a is minus 1, what will happen is you get f double dash x equals to a term like that. 2 over x minus 1 to the power 3 minus 2 over x plus 1 to the power 3. The reason why it's also not equal to 0 or no solution is because you can either solve it and establish maybe a contradiction. If f double dash x equals to 0, you have 2 over x minus 1 to the power 3 equal to 2 over x plus 1 to the power 3. eventually you'll get something like x minus 1 to the power 3 equals to x plus 1 to the power 3. And then taking the cube root both sides, you get x minus 1 equals to x plus 1. Then you get minus 1 equals to 1, which is a contradiction. Therefore, no solution to f double dash x equals to 0 when a equals to minus 1. Therefore, no point of inflection on y equals to f of x when a equals to minus 2 or a equals to minus 1. Let's conclude in this one. Or you might want to say common denominator. You can actually take a common denominator and get a 12x squared plus 4 over x minus 1 to the power 3 times x plus 1 to the power 3. But the numerator is never equal to 0 because this is just always greater than or equal to 4, okay? Something along this line. So let's move on and look at next question. Question 2, 10 marks. Show that the relation z minus 2i absolute value equals to imaginary z plus I, where z is x plus iy, and it's given by 6y equal to x squared plus 3. So what I'm going to do is first write x plus y minus 2i equals to imaginary x plus y plus 1i. And the left-hand side is going to be x squared plus y minus 2 bracket square equals to just y plus 1. And you can actually square both sides. So for example, you get x squared plus y minus 2 bracket square equals to y plus 1 whole thing squared. And you will actually get x squared plus y squared minus 4y plus 4 equals to y squared plus 2y plus 1. And then you can just rearrange. It's like these two terms will cancel each other. So you have x to the power 2 plus 4 minus 1. That's 3 equals to 6y as required. Okay, so that's a show that question. And we want to sketch the graph of this relation on the Argand diagram below for x between minus 3 to 3. And we are actually sketching 6y equals to x squared plus 3. So y equals to 1 over 6x squared plus a half. So this is a quadratic function, and we definitely have a 0 half here. And if we solve it, for example, a 3 and a minus 3, you might want to, let's say, create a new problem, add a graph. We'll also use x squared plus 3 divided by 6, something like that. Just zoom in a little bit. Scale is 1. This is 0.5. So actually you will get, let's say, it's a 3 here and a 3 here. So probably would say, just let me have a look. This is a half. So that's 1, 1.5, 2. So get a point here and get a point here. 3, 2 minus 3, 2. And what else do we have? Yep, pretty much what I need. So I can just get, for example, I might want to calculate a couple of extra values. Say 1, 2, 2 on 3, 7 on 6. Remember, your parabola should look symmetrical. I should use pencil, but anyway. Right, that is possible graph. Let me have a look at the back. If it's not too, okay, a little bit. But anyway, yeah, that is a parabola. I label the endpoints with the coordinates. Yeah, labeled. A ray from the origin O is tangential to the part of the curve where x is greater than 0. Sketch the ray on the Argand diagram above and find the equation of this ray in Cartesian form. Well, it's a tangent. Maybe it's something like that. Okay, I'll use pencil in this case. It's a ray, so this should be a hollow circle at the origin, okay? A hollow circle. And it's a tangential point here, roughly, very close to y. Find the equation of this ray. So I'm going to say dy dx equals to 2x divided by 6. That is x to the power of 3. And also, let's say the tangential point is x, comma, x squared plus 3 divided by 6. So I can actually get the gradient between these 2 points equal to x over 3. So we have x squared plus 3 divided by 6 divided by x. So this bit is x equals to x on 3. So this is a classic mathematical type question. And then we have solve f1 of x divided by x equals to x over 3 comma x. We have plus or minus root 3, but x is greater than 0. Therefore, our x is just the square root of 3. Of course, if you are familiar with math method entries, you just go for menu 4, 9. f1 of x comma x square root of 3. So this line is root 3x over 3. Because this is right. Starting from the origin, I put x greater than 0. The question only says find the equation of this ray in Cartesian form. It doesn't specify domain. Maybe I can leave off the domain, but I just leave it like that. It's definitely true. X greater than 0. And I find the point of intersection of the ray with the curve. Express your answer in the form a plus bi. A, b are real numbers. So you can see this is 1. The gradient is root 3 over 3. So maybe it's just a root 3. Y value, I would say root 3 plus I. Okay, I can verify this one. So f1 of square root of 3. That's 1, yes. So that is the requirement. Okay, let's have a look. Sketch the graph of the relation z bar minus 2i is imaginary z bar plus I. Z is x plus yi. On the Argand diagram provided in part B, labeling it with its Cartesian equation. So if I have z equals to x plus yi, I have z bar equals to x minus yi. So this is like a reflection in the horizontal axis. And the old equation was y equals to x to the power 2 plus 3 divided by 6. The new equation should be reflection, so just put a negative x squared plus 3 divided by 6. So it's flipping that upside down, flipping the black curve here. Okay, so I need to go back to part D and sketch this one on the Argand diagram here. I use a different color. Zero half becomes 0 minus half. And here, 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 and here. Okay, so this is 3 minus 2. This is minus 3 minus 2. The question didn't give any domain restriction for part D. So if you wish to extend that a little bit, I think it should be fine. But importantly, you need to label this is y equals to minus x squared plus 3 divided by 6. And this was y equals to x squared plus 3 divided by 6. This is the old curve. This is the new curve. Anyway, the line that passes through the point z1 equals to minus 1, and z2 is 3 plus 2i. Has the equation here. Find the values of c and d. Only 1 mark, no working required. So better use my CAS calculator. Okay, so I have an absolute value. Z equals to another absolute value, z minus c plus d times I. Given that z equals to minus 1, that's one equation, and 3 plus 2i, that's another equation. Let's solve these two equations. Just be mindful, CD should not be equal to 0, so you just get a minus 2 on 5 and a 4 on 5. Yep. Or if you wish, you could say C equals to minus 0.4, D equals to 0.8, something along this line. Actually, it shows a perpendicular bisector, and this perpendicular bisector goes through minus 1, 0, and 3, 2. Bear with me. And then we want to find the area of the region enclosed by the curves. Okay, straight line, and all right, this is another mathematical question, to be honest with you. So you have a parabola, and it goes through here. Let me just point them out. A segment, minus 1, 0, and a 3, 2i. It's this location here. Okay, it's this location here. So I can right-click this one, and couldn't get that, but at least I know what's happening. Area or region enclosed by these two. Actually, let me think about this one. I can get an equation, and the equation is okay. Here is the way I will interpret this one. Gradient is like a 1 over 2 over 4. And yep, seems that it cuts through a half here. Y equals to 1/2 times x minus y. Okay, and if we solve an equation equal to f1 of x, comma x, now oh, sorry, x plus 1, bear with me. Oh, it's 0 to 3. So I actually need to get, let's say, 0 to 3 and do an integration. We have this one subtracting f1 of x, comma x. Oh, this answer is very simple, 3 over 4. Okay. Right, it's this segment. If I plot, let's say, x on 2 plus a half. Yep, it's this line here. Maybe I can just delete this point and delete this point. bounded area from here to here. Yeah, 0.75, very simple. So let's say equation of the line is y equals to half x plus half, something like that. So half x plus half equals to f of x. I'll say f of x equals to x squared plus 3 on 6 gives me x equals to 0 and x equals to 3. But actually, this one can be just observed by the graph. So the area equals to 0 to 3. Half x plus half, subtracting f of x dx. So actually, I get 0.75. Yep. Done. I will look at the next question. Let's keep looking at the rest. Question 3, integration. Okay, volume. Okay, dish logistic equation. That's interesting. This is I3x is secant to the power 3. It's a very famous integral. Use integration by parts to find an expression for I3x involving secant x, tangent x, and I1x, where I1x is integration secant x dx. So I say that u dash equals to secant squared x, and v equals to secant x. U is going to be tangent x, the antiderivative of secant squared. And the v dash, if you go to the VCAA website, you see a copy of the VCAA formula sheet, and it provides you derivative of secant is secant tangent. Therefore, I3 of x equals to tangent x, secant x, that's u times v, minus u times v dash. So you will have secant x times tangent squared x dx. Okay, and then we want to express this one in terms of a secant, so we try to get as many secant terms as possible. I can't move the first term, tangent times secant, but I do notice the second term can be written as a secant squared x minus 1 dx. And then I'll get tangent x, secant x, subtracting maybe a secant to the power 3x dx, and a minus times minus, that's a plus. It's a plus a secant x dx. So for each integral, you should write the dx. And then this term is my I3 of x again. And this term is my I1 of x. Therefore, I have I3 of x equals to tangent x secant x. Of course, I can just add this I3 to the other side. That's 2 lots of I3x plus I1 of x. And I3 of x is just half tangent x secant x plus a half I1 of x. If you wish, you could put a plus c here, but this plus c, is that optional? I can argue the plus c is combined in, let's say, I1 of x, which is a secant x. So let's move on. The graph of y equals to I1x, which is the integral graph for x between minus half pi to half pi, is shown below. The part of the graph where x between pi on 6, comma pi on 3. Why is that? It's a bit extra space here. is rotated about the y-axis to model the curved surface of a small laboratory dish. The dish has a flat circular base and an open top. One unit on each axis represents 1 centimeter. So the derived unit for volume should be centimeter cubed. Okay. Use Vx equals to pi integral x squared dy dx. Find the volume of the fluid needed to completely fill the dish. Give your answer in cubic centimeters correct to 1 decimal place. So if y is I1, x dy dx is just secant x. And do I need to, actually, this is an x squared, this is secant x, this is dx. And my integration goes from the y value here to here, but we can actually change back to pi on 6 to pi on 3. So v, do I need the x? V of x is pi integral x squared times secant x dx. And therefore we say v dish is x1 to x2, pi on 6 to pi on 3, x squared secant x dx. I just need to calculate this one using my CAS calculator. Alrighty, so let's have a look. Pi shift plus pi on 6 pi on 3 x squared sec x dx. Okay, 1.6. The dish is used to study the growth of a certain type of bacteria. Initially, 500 bacteria are in the dish, and the number of bacteria present after 10 minutes grows according to the differential equation. What's the maximum value? Okay, maximum value means maximum asymptote. So as t approaches to infinity, dn dt approaches to 0, and n is not approaching to 0, so n should be approaching to n max, approaching to 15,000. Okay, so that is the maximum upper bound population. Initially 500 bacteria, so t equals to 0, n equals to 500. T equals to, let's say, capital T, my n equals to 7,500. Definite integral as the time it would take for n to reach 7,500. Okay, so we need to get, let's say, delta t equals to the integral from 500, 7,500 dt dn. And we just write 500, 7,500, 1 divided by 0.05 n, 1 minus n divided by 15,000 dn. Just flip that over to get dt dn and integrate the flipped function over 500 to 7,500 and find the time it would take the number of bacteria to grow to 7,500. Give your answer in minutes, correct to 1 decimal place. Yeah, after 10 minutes, okay. It's an interesting combination of volume of revolution and logistic differential equation. Okay, so the answer is 67.3. Looks like an exact value anyway. All right. And that d2 and dt squared equals to n over 400 times 1 minus n over 7,500 times 1 minus n over 15,000. Show calculations to verify that a graph of n against t has a non-stationary point of inflection where n equals to 7,500. 2 marks. So what I'll write here is first, for non-stationary point of inflection, we need the second derivative equal to 0, but my first derivative is not equal to 0. If my first derivative is not equal to 0, then look at the structure here. Your n cannot be 0. Your n cannot be 1,500. So n times 1 over n 15,000 is not equal to 0. Therefore, I can knock out these two factors. Then 1 minus n over 7,500 equals to 0 only. And n equals to 7,500. And then verify a point of inflection. I think if you look at the past, especially the recent VCAA exams like 2020, you would have to verify, for example, the sign change near this value. So a quick method. Okay, because the bacteria is starting from 500. I'll say, okay, for n between 500 to 7,500. This first term is positive, and this term, if it's less than, the n is less than 7,500, one take away a number less than 1, which is greater than 0. You say 1 minus n over 7,500 is greater than 0. And then this one is also greater than 0. 1 minus n over 15,000 is greater than 0. Therefore, d2n dt squared is greater than 0. And then for n between 7,500 and 15,000, your 1 minus n over 7,500. This is a number larger than 1 now. So one take away a number larger than 1 should be negative. And 1 take away n over 15,000 is also greater than 0. So your d2n dt squared is less than 0. We multiply these two together. Therefore, a sign change at n equals to 7,500 is confirmed. Okay. The question says show calculations. Yeah, you could say this is a calculation, but do they really mean like choose a suitable value, let's say 5,000, sub in here, get a positive value, and choose let's say 10,000, sub in here, and get it less than 0. I'm not entirely sure, but I think this is a decent way to verify the sign change according to the intervals of values in the context, okay? Anyway, I'm gonna move on. Question 4. It's a dark Cartesian equation. This is a vector function at a time t seconds between 0 and 10. Find a Cartesian equation of the path of the dark. Okay, so I say x equals to 2 minus 5 cosine t. Y equals to 1 minus 6 sine t. And you just say x minus 2 divided by negative 5 equals to cosine t. And a y take away 1 divided by minus 6 equals to sine t. So this is a classic type of 2 marks question. Like some rearrangement here, isolating the cosine and sine term. And then use cosine squared plus sine squared t equals to 1. Then you would get x minus 2 bracket squared divided by 25 plus y minus 1 squared divided by 36 equals to 1, okay? So that is the Cartesian equation. And the next part wants you to find how far does the dog travel along the path in the first 5 seconds. Give your answer in meters correctly, 1 decimal place. 5 seconds from t equals to 0 to t equals to 5. So you might want to use, let's say, arc length formula from 0 to 5. Square root something squared. The derivative of this is minus 5 sine t. And the derivative of the j component is minus 6 cosine t. Actually, this is a plus. Cosine derivative is negative sign, so positive. Yep. This is squared. And then you just integrate that from 0 to 5. I might want to define this function. Say Rd of t is assigned to 2 minus 5 cosine t, comma 1 minus 6 sine t. Velocity t is assigned to the derivative Rd of t, comma t. And integral norm Vd of t, t 0 to 5, control enter. 27.4183, which is rounded to 27.4 meters. The dog is to be monitored by a drone. The drone is dispatched at t equals to 0, and its velocity is given by these things. Components are measured in meters per second, and ABC are real constant. Initial position is 20I plus 30J. Maybe you can put a plus 0K. Use integration to show that. Okay, this is the, yep. Interesting to see a 1 mark. So first of all, you're gonna get R of capital RT equals to the integral of R dot RT dt. So each component you get A over 2t squared plus 20t. Put an I here, plus B over 2t squared plus 30t. Put a J here, and a plus C on 2. Actually, it's not C on 2, C on 3, because it's going to be t to the power 3 plus t squared times k. Add an integration constant, let's call it d. And then we say R of capital R0 equals to 20I plus 30J plus 0K equals to, that's a 0, 0I plus 0, 0, 0J plus 0K plus D. So your D equals to 20I plus 30J. Therefore, when you combine them together, R capital RT equals to, just make sure you copy down everything correctly. So I merge this 20I into the first component and merge this 30J in the second component. And the last component doesn't have any number added to it. Okay. That's why they only provided 1, 2, 3, 4, 5. 5 lines. You have to show your antiderivative, show your determination of integration constant, and make a conclusion, something along this line, I suppose. And find the values of ABC if the drone reaches the dock when t equals to 10. That is R of D10 equals to R of capital R10. I want to use this one to construct 1, 2, 3, 3 equations. One thing is, like the K component, you will immediately tell 10 something here, that's 1,000, C divided by 3 plus 100 equals to 0, something along this line. So then you have to solve here, 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 and then equate to the ij component in the previous vector. So let's do RD of 10. We'll get something like that. Eventually it's decimal places, so it doesn't really matter. So if I have, let's say, RR of t is assigned to a on 2 times t squared plus 20t plus 20, comma, b times t squared divided by 2 plus 30t plus 30, comma, c times t to the power 3 divided by 3 plus t squared. Should have everything. And RR of 10. Okay, something along this line. Just compare them. So I have 58 plus 220 equals to 6.19535 dot dot dot. And that's I component. J component, you have 50b plus 330 equals to 4.26412 dot dot dot. And the K component, it has nothing in the previous vector, like it doesn't have the K component, so just treat it like 0. So you have 1,000 C divided by 3 plus 100 equals to 0. So you have those 3 simultaneous equations and solve them. Solve 3 of them. So this one is 0. This one is 6.1 something. And just grab this one here, equals to 4.26 something. Comma A, comma B, comma C. Control Enter. Therefore, A equals to, B equals to, C equals to. C is minus 0.3. Everything correct in one decimal place. So A is minus 4.3. B is minus 6.5. There we go. Okay. At what time is the duck closest to the initial position of the drone? Give your answer in seconds correct in one decimal place. So initial position of the drone is like, okay, we can have, let's say, a displacement vector equals to R of dt minus 20i plus 30j. So the distance, we call it capital DT, equals to displacement magnitude, that is R dt minus 20i plus 30j. Something along this line. And it's worth 3 marks. Okay. So you probably need to construct, let's say, distance function. In this case, if you look at the equation, okay, so if I have that, 2 minus 5 cosine t minus 20, so I should have minus 18 minus 5 cosine t squared plus 1 minus 6, take away 30. So minus 29, take away 6 sine t, something along this line. Alternatively, you might want to do, let's say, norm RD of T, take away 20, 30. It will give you something along this line. Then you just get F minimum. E, notice that the domain restriction for RD is 0 to 10. So we press Control Enter. And this is a T value. And the question didn't ask for the shortest distance, so we can just stop here. But if you really want to find the shortest distance, this is a substitution. So the shortest distance will be 28.4 meters, etc. Okay. Okay. So this is optional, okay? You don't have to specify this. This is just my personal habit. If I found the t-value, I'll just find the shortest the smallest value or the maximum value altogether. All right. Question 5. You have PQST. Given that OP is MOQ plus NOT, so they are linearly dependent. Find the value of A. You might want to create, let's say, 3 simultaneous equations, but you could also use, let's say, OP, OQ, and OT. The 3 things are, they can form, let's say, A minus 4, and OQ is like -3, -4, -2, and T is like 2, 3, 2, equals to 0. So you can actually get, for example, that a 3 by 3 matrix, A minus 4, minus 4, minus 3, minus 4, minus 2, 2, 3, 2. Okay, and that's equal to 0, so A is minus 2. Okay. If you want to find the vector cross product of QT times QS, I'll first get, let's say, QT is T minus Q, OT minus OQ, so 2, 3, 2, minus -3, -4, -2. So get a vector like that, and QS is like 5, 4, minus 2. Take away Q, that is -3, -4, -2. So get 8, 8, 0, and then we do cross P, QT, QS. Don't reverse the order. Cross product is not interchangeable like dot product. So this is what you're going to get. QT equals to 5i plus 7j plus 4k. QS equals to 8i plus 8j plus 0k. So QT cross QS equals to -32i plus 32j minus 16k. Okay. Find the Cartesian equation of the plane pi1. So pi1 should contain QTS 3 points here. So this vector must be a normal to the plane because we use the 2 spanning vector to create a cross product. This is parallel to the normal vector. Then we take a look. Express the answer in the form ax plus by plus z equals to c. A, b, c are real numbers. Notice that it's not like ax, by, c, z. It specifically gives you, let's say, a number 1 there. So, for example, your n vector, notice the ratio is minus 32 to 32 to negative 16. It can be converted to the ratio. I mean, the IJK ratios can be, if you divide by negative 16, you get 2 minus 2 to 1. Okay? So you can also say let n equals to 2i minus 2j plus 1k. So the pi 1 may well be, let's say, 2x minus 2y plus z equals to some constant c. For example, your a value must be 2, b value must be minus 2, okay? And then you just need to pick a point. Let's say QST. Pick a point. Let me just take t, okay? Pick the coordinate t like 2, 3, 2. And the subbing pi 1. You get, let's say, 4 minus 6 plus 2. Oh, that's actually equals to c. And c equals to 6 minus 6. Oh, that's a 0. Therefore, the Cartesian equation of pi 1, that is 2x minus 2y plus z equals to 0. There we go. Problem solved. Okay. A second plane pi 2 has an equation u squared x plus 9uy plus 3z is 13. It's certain u is real. Vector st is parallel to this plane. Find the possible values of u. Okay, so suppose I have a plane and the vector, let's say this is s, this is t. I don't care about the orientation. But if this vector is parallel to a plane, I couldn't actually use any vectors in the plane, maybe here, here, or here, because it has infinite number of directions. It doesn't help. But one thing unique regarding this plane pi 2 is the perpendicular vector. So we say the perpendicular vector 2 equals to u squared I plus 9uj plus 3k. And the next thing is, if this vector is parallel to the plane, then it has to be perpendicular. It has to be perpendicular to the normal vector. Because if you have another parallel plane to this plane here, okay? That's a different story. So we try to find ST. Vector S to T. S to T, you might want to use ST is assigned to QT minus QS. So it's minus 3 minus 1 4. Okay? Minus J plus 4K, something along this line. Then N2 must be perpendicular to ST, and that gives me u squared I plus 9uj plus 3k dot minus 3i minus j plus 4k equals to 0, okay? And I just need to solve the equation. Possible values of u. So I'm going to say dot product that u squared, comma, 9u, comma, 3. And solve that equal to 0 for u. Minus 4 or 1. Problem solved. Finally, what is the shortest distance from point Q to the line that passes through the point S and T? So let's say we have a Q, we have an S, we have a T. I would like to get the shortest distance from point Q to ST. Okay, well, then we have multiple methods, okay? We can use whatever method we like. In this particular instance, to be honest with you, I know there are at least 5 to 6 methods, but one method I'm going to apply here is calculus. So the line ST can be given by RST of, let's call this small t. We may choose the starting point to be, let's say, the S, okay? S has the coordinate 5 something I plus 4 something j plus minus 2 something k, something along this line. And a direction vector, because we found ST before, we can take negative 3t, negative t, and plus 4t, something along this line. And the location of Q is going to be location of Q is -3, -4, and a -2. Remember, this position vector is relative to the origin, and these 3 coordinates values, they are all relative to the origin. That's why we can create a distance function. Is the magnitude of RST small t take away OQ, vector OQ. So we can actually form, let's say, R of t is assigned to 5 minus 3t, comma, 4 minus t, comma, -2 plus 4t. And the distance of t is assigned to norm. R of t take away -3, -4, -2. And I can use F minimum, D of t, comma t, 16 over 13. So D of that is 24 root 26 divided by 13, okay? Yeah, you can actually show some working here. And evidence of an expression. And D dash T equal to 0 or F minimum. And this is the quadratic expression. It gives you T equals to 16 over 13. Therefore, D minimum equals to D of 16 over 13. That is equal to 24 square root 26 over 13 units, okay? You might want to use other method. For example, I can also use dot product as minus QS. Or actually, I can use QS and unit vector ST. And yeah, I can get, let's say, some kind of a scalar resolute of SQ onto ST. And then I can just find the distance of SQ and use Pythagoras. Like a norm of QS is this guy here. Then I can just take a square root. That thing squared, take away that squared. It gives you the same answer, okay? There are heaps number of method you can use cross product like SQ cross the unit vector of ST and taking the magnitude, you still get the same answer, etc., or calculus or dot product or perpendicular vectors. So many other methods. But make sure you write your answer in this format, okay? Shortest distance problem. Okay, last question for VCAA statistics. Okay, manufacturer produced a bicycle in 3 stages. 3 stages, 1, 2, 3. Mean value, standard deviations. Standard deviation of the total processing time to produce a bicycle is 1.5 hours. So we know the variance of T total. is variance of T1 plus variance of T2 plus variance of T3, I suppose. Bear with me. So left-hand side, I have 1.5 squared. Right-hand side, we have 1 squared plus a squared plus 0.2 squared. We just need to solve an equation. Notice that this a has to be positive, okay? A is a positive real constant, actually. So we can just solve for that. And let's just grab a calculator problem. And then solve 1.5 squared equals to 1 squared plus a squared plus 0.2 squared, comma a. The answer is 11 over 10 or 1.1. What is the probability that a total time taken to produce bicycle exceeds 20 hours? So the T total is a normal distribution. The mean value is 5 plus 8 plus 3, that is 16. The combined variance is 1.5 squared. Therefore, I would like T total greater than 20 hours. I can use norm CDF. Sounds reasonable. 0.00383 and 0.0038 for decimal places. Okay. The heights of people in Australia may be assumed to be normally distributed with a standard deviation of 10. The bicycles are designed for people of varying heights. The manufacturer takes a random sample of 150 people. N equals to 150. Mean height, X bar is 169. And a sigma equals to 10. That's the population standard deviation. 99% confidence interval. 200 such samples. How many of the 99? Okay. 200 times 99%. So it's like 198 confidence intervals expected to capture the mu value, okay? Something along this line. And let's do part C. Confidence intervals, Z interval, stats. Okay, sigma is 10. This is 169. Really? Is that the mean height in Australia like 169? Okay, right. I suppose it should be 170 something. Anyway, this is just my feeling. 150, 0.99. Well, thinking about myself, I'm definitely an outlier because I'm 192 centimeters tall. Okay, so it's 166.9 and 171.1, rounded to 1 decimal place. So 166.9, 171.1. Okay. The VCAA formula should use round brackets. I use round bracket, okay? But if you want to use a square bracket, technically speaking, it's not wrong, I would say. The manufacturer wants to get a better estimate of the population mean by decreasing the width of the confidence interval by at least 60%. What's the minimum sample size taken to achieve this? So the old margin of error can be expressed as the z-score times the standard deviation divided by square root 150. And the new margin of error is z-score. Actually, I can time 2 here. I should times 2. Times 2, that's, let's say, the width, but you can just analyze the margin of error. That's enough. New margin of error is z times sigma divided by an unknown n. If you decrease by at least 60%, then how much remaining? remaining at most 40% of original. So this thing should be less than or equal to 0.4 times z times sigma divided by square root of 150. Okay, 0.4 lots of the old bit. And you can cancel out the z, the sigma, the z, the sigma, and just get 1 over square root of n less than or equal to 0.4 times 1 over square root of 150. Just solve that. Solve 1 over square root of n less than or equal to 0.4 times 1 over square root of 150, comma m. So you actually get n greater than or equal to 937.5, which means the smallest sample size should be 938. You can't take 937 because that does not lie within this inequality. You have to, let's say, choose the minimum whole number value within this inequality. Okay. Bicycle tire life is defined as the number of kilometers. So anyway, manufacturer claims that the mean life of the bicycle is 3,200 kilometers. Now our hypothesis mu equals to 3200. A large number of customers reported that the bicycle tires had a tire life of more than 3,200, which is a good thing, okay? But we need to stick to the script of hypothesis testing. And we want to use, one-sided statistic test. Standard deviation 450, 5% level significance, a sample of 100. Mean is 3,300. Standard deviation still 450. P-value of the test. Okay, so find a p-value, make a conclusion. Let's have a look. Menu 6, stat test, z test, stat. Mu naught is 3200, sigma is 450, x bar is 3300, n is 100. We use the larger than. Okay, press Control Enter. So we say x bar is a normal distribution, 3200, comma 450 squared divided by 100, something along this line. And p-value is probability x bar greater than or equals to 3,300, given mu equals to 3,200. And that gives you 0.01313,410. Rounded to 4 decimal place, 0.0131. And this p-value is less than 0.05. Therefore, reject H naught. So the mean value should be, because we reject H naught, mean value should not be 3,200. It should be greater than 3,200. Kilometers. And yes, the manufacturer should change the claim. In my opinion, this was similar to the 2024 November exam. You should actually answer the question rather than just say reject H naught full stop. That's not enough. You will have to, let's say, give some reasoning and give your clear conclusion to address the question. Because the question was not asking for whether or not you reject H naught. Suppose that the true mean bicycle tire life is 3,350 kilometers. Find the probability correct in 3 decimal places that the manufacturer will still conclude that the mean bicycle tire life is 30 to 100 kilometers. So fail to reject H0. This is an incorrect H0. This is a type 2 error probability. Okay, so we would like to find first, under the old assumption, we would like to have the sample mean greater than or equal to C star under the old mean for the critical value on the right, okay? So let me just draw a diagram. For example, this is 3200. This illustrates a potential X bar. And I would like to get some C star here. This bit is like your alpha equals to 0.05. And at some stage you get, let's say, a curve like that. Okay, this is the actual mean. Mu1 equals to 3350. So you can see it's actually larger than 3200. This is the actual, this is the claimed, okay? And if I use a different color, this is gonna be my beta, okay? This is my alpha. This is my beta, okay? So I'm actually getting the C star, and then I'll calculate probability X bar less than or equal to C star given mu equals to 3350. That's equal to something, okay? So it's a two-stage problem. Inverse norm, 0.95. Because under the older curve, the right tail is 0.05. The left tail, cumulative probability will be 0.95. 3200, and the standard deviation was 450 divided by square root of 100. So this is a critical value. 3274.018 kilometers. And then we just put this back in norm CDF minus infinity to this value, 3350. That's the actual mean, and 450 divided by 10, or square root of 100. So the answer is a very small value, 0.04565. Correct to 3 decimal places, 0.046. Therefore, the probability of type 2 error, committing a type 2 error, is 0.046. Okay. Hopefully you find this video helpful. I'll see you in another time for the 20 multi-choice questions. Bye-bye.